Well, hello scrappers and amateur chemistry enthusiasts. Welcome back to my channel. I've got a little experiment going on here in this beaker. What this is some of my own waste liquid from getting gold out of IC chips. It produces a lot of mixed metal nitrates liquid. There's obviously a lot of copper in there from the color, you can tell. But there's other metals in there too. There's iron, there's zinc, and there's who knows. So basically it's all mixed nitrates. And what I'm going to do is I'm going to try and make some new nitric acid out of this old waste material. So I don't have to buy so much nitric acid to get gold out of the IC chips, and that should improve the profitability of my process some. So how am I doing this? Well, over here in the fume hood, I'm just boiling down some of my waste liquid. Concentrating it. I've already boiled, well, not boiling, just slowly evaporating. It's on low heat, it's not high heat. I don't actually want to boil it because I can drive some strange reactions in this stuff. I've tried overheating this stuff and some weird stuff goes on because of the mix of nitrates in there. But I'm just slowly evaporating it over low heat. I started this yesterday. I have about 2 gallons of mostly copper nitrate with some other metal nitrates mixed in, like iron and zinc and whatnot. I evaporated it down to about half of this much and then filled it back up, and I'm going to keep doing this until I get a really, really concentrated solution. And then I'll let it crystallize. Now I'm also getting, I don't know if it's showing up, I'm getting some precipitation out of the liquid. I think that's iron oxide coming out. That will happen, and that can happen pretty energetically if I overheat this stuff too. The iron nitrates in there will oxidize to iron oxide and come out of solution. So, but you know, that's okay. I can always filter this before I let it crystallize and get that gunk at the bottom out of it. Yeah, like I say, I've got about 2 gallons of this liquid. I used it as electrolyte in my copper refining cell for the first run of the cell. So I'm not going to reuse it for the next run of the cell. I'm going to make a different electrolyte. So I'm just going to try and concentrate the salts in here down and crystallize them out and see if I can make some fresh nitric acid out of them. So we're just going to keep this up over the next few days or a week and see just how much of this 2 gallons of liquid I've got I can reduce to something like this. This was probably about 2 liters of liquid that's been reduced to this stuff down here. And then we'll try and make some nitric acid out of it. We'll use it as feedstock for trying to produce some more nitric acid. And we'll see how it works. Here's another project, which I may talk about in another video. Alright, so got some evaporating to do. Be back in a few days or a week. Okay, it's been a couple days. Low heat, slowly evaporating. I'm gonna, we're down to just above 800 milliliters here, so I'm gonna add the rest of this gallon of used electrolyte solution in here with its mixed nitrates. That brings us up to about 1,400 liters again. And we'll keep it evaporating. I'll start on the 2nd gallon and get that in there. I've decided, I've been thinking, I'm not sure I'm going to bother filtering that sediment out of the bottom. I may just leave it there. I don't think it'll hurt anything when it comes to trying to convert whatever crystals grow in this into back into nitric acid. So I think I'll just leave it because more is just going to keep forming, and filtering a hot liquid is never a good idea, even though this is really only warm. Still, it's not a good idea because filter papers can fall apart. So I think I'm just going to leave it because I know as soon as I cool this, a bunch of crystals are going to drop out of solution. So, but I don't think that sediment's going to hurt anything. So I'll just keep evaporating. This goes down a little more. I'll start on the 2nd gallon. Well, I guess it's been, I don't know, a few days, a week or so since I've been working on this. I've been evaporating it down. I'm on the 2nd gallon, and it's almost gone. So this stuff in here is getting really, really concentrated. Now, I just released the previous video on this subject this morning, growing the crystals, and just tremendous feedback on that. Thank you. I appreciate it, everybody who commented. Apparently, I am not the first person to have problems with thermal runaway on these nitrate salts once they get really concentrated. So I'm going to have to be careful of that in the future. Now, this should not have any urea in it, but apparently, according to the comments from one fellow, it doesn't matter if there's any organic stuff in it. The ferric nitrate can, or ferrous nitrate, whichever, the iron nitrates can just run away on their own, even without any organic matter in there to help fuel the fire, so to speak. And I was kind of suspecting that that's where the initial reaction came from. So, yeah. So I will be careful. I will be a little more careful. But boy, this is getting really concentrated now. Okay. Get the rest of this stuff in there in the next day or two. I'll evaporate it. See if I can evaporate it down to about 1,000 milliliters or so. And then turn the heat off and see what kind of crystals crash out of solution, and then I'll pour off the liquid again and continue concentrating that. But I won't try too hard to bake the crystals dry, because that's not easy, may not even be possible, may result in another thermal runaway. So gotta be a little more careful this time, you know, don't want that to happen again. Okay, so we're just going to keep evaporating. Be back when we're done. Alright, this has been going on for weeks now. Evaporating down this 2 gallons of liquid. And for the past few days, the level has been stuck at just above 1,200 milliliters. It doesn't look like it's evaporating any further, really. We're getting a crust of crystals on top of the beaker. So I think what I'm going to do, this has been on warm heat the whole time, it's just warm. What I'm going to do is I'm going to turn the heat off, and we'll see what kind of crystals crash out of solution overnight. Now it's not going to get particularly cold tonight, but it will probably get down into the 60s Fahrenheit anyway. And this is pretty warm right now, so I have a feeling we're going to get a lot of crystals crashing out of solution. And what I will do is I'll drain off whatever liquid is left, and I will try continuing to evaporate that. But yeah, not getting much more out of this. Maybe the crust of crystals on top is preventing further evaporation. I don't know. But boy, that's getting concentrated. So okay, we'll see what we got in the morning. Well, it's the next day, and it didn't get very chilly overnight, but nonetheless, yeah, look at all the crystals in there. Okay, so what I will do is I will pour off the remaining liquid and see if I can evaporate that down some more, and I will save these crystals for later processing. This worked out pretty well. Alright, let me pour off this liquid. And just like with my small scale test, this stuff is really thick. It's like maple syrup. And look what's staying behind in there. Wow. Those are some deep blue crystals. Now, I did put a little bit of copper sulfate in the electrolyte of the refining cell back when I was first experimenting with trying to bring the conductivity, make the cell more conductive, basically. So this has got a little bit of copper sulfate in it, as well as mostly copper nitrate and some other mixed metal nitrates. So most of these crystals are actually going to be nitrate salts. There's just going to be a little bit of copper sulfate and maybe other metal sulfates mixed in. Okay, so this is probably going to take a while. I will just let this drain, and then I will put this on low heat and see if I can evaporate any more of it. If it's anything like the small batch I did as a test, it'll probably lose about 100 milliliters and then turn into solid crystals. We'll see. Okay, I've improvised a little stand here to sort of drain the rest of the liquid off. Slowly, it's dripping out slowly. But you can see how much iron oxide has come out, at least I hope you can see that, out of solution there. And there's bands of it up in here too. But boy, there's a lot of blue crystals in there. Holy cow. So I'm just going to continue to let this drain, get these crystals as dry as I can up here, and then set them aside for further processing later. And we'll evaporate this stuff down. Here comes another drop. This has been dripping for literally 2 hours now. Just every once in a while, here comes another drop. Here it comes. Yeah, there we go. So, yeah, the liquid is coming out of the crystals in there very slowly, but it is coming out. But I'm losing patience with it because I need my workbench here for another project. So I'm going to call this in a bit and just live with that as it is for now, and then get this back in the fume hood and get it evaporating down, and start on something else up here on my workbench. Okay, so here's the big beaker full of crystals back here, just covered up, just going to sit there until I can do something with it. Got the small beaker with the liquid in it. I'll tell you what, that is some dense liquid. My God, that's heavy. For what, a little over 600 milliliters of liquid? Wow, there's a lot of salts dissolved in there. So I'm going to put this on to low heat and see if I can evaporate away any more of that liquid, and see if I can get it to evaporate down a little bit more and crystallize. We'll see. Again, very low heat. Don't want to have any kind of thermal runaway reactions like I had with my small scale test, because some of these salts are a little unstable. If they get a little too dehydrated, strange things happen. Okay, so now it's just a waiting game. Okay, the level on this liquid just isn't going down. It's been on fairly warm heat for over a week now, and we're kind of stuck at 600 milliliters. It's just not going down. I think what we've got here is melted salts rather than water that can be evaporated now. So what I'm going to do is I'm just going to turn the heat off on this, and like I did with the big beaker back there, we'll see what happens overnight. I'll bet we're going to get a whole lot of crystal growth out of this when this stuff cools down now overnight. And I need to find something to store these crystals in until I'm ready to try and process them, because I got 1, 2, 3 beakers. Now that one in the back corner back there is my prototype one. So I got 3 beakers now full of these blue nitrate crystals. So I got to get something to store them in so I can get my beakers back and use them for other things. Okay, we'll be back in the morning and we'll see what we've got here in this beaker. Okay, it's the next morning, and strangely not much seems to have happened at first glance, but yeah, there's a lot of crystals in there. They're basically stuck to the sides of the beaker, and there's just liquid in the center. So this was liquid. There's a lot of crystals at the bottom too. Yeah, this was liquid except for a rime of crystals around the top. So a lot did crystallize overnight. It didn't get super cold last night, but yeah, it got cold enough that we got some crystal growth there. Let me pour that liquid out, and we'll see what kind of crystals we got in here. So let me move stuff over onto the bench. Okay, I got my lab helping hands out here. Just this grip barely opens big enough, or this gripper barely opens big enough to hold a 1 liter beaker, but it's holding it, and it's in there good and tight, so I'm not too worried about it slipping out. So we'll just let this sit and drip and dry out the crystals in there as best we can. It may take an hour or more like it did last time. I don't know. I don't think there's much liquid in there as before, but boy, there's a lot of crystals in there. That's nice. And we got more liquid to evaporate down. I imagine it'll lose a few milliliters and crystallize up again too. Okay, let me get to working on storage options and start getting the crystals in these beakers over here into something more permanent. Okay, I managed to scrounge up a quart mason jar, so this might be a good start. I don't know what that is. Something outgassing from in here. Let's see how hard this stuff is. It's pretty hard. I don't know if I'll be able to get it out with this spatula. I might have to dig it out with something metal. Yeah. They're a little damp, but they are hard in there. Alright, let me see about this one here. Got in here. I can get some of the crystals loose anyway. Yeah, I'm definitely going to need something tougher than this spatula. Especially the stuff that's around the edges, it just doesn't want to come off. In the center, it's a little looser. Actually, you know what? I think I know what I can use. I'll go see if I can find it here in a second. Wow, this is some really blue stuff. Alright, let me just see if I can find something better to dig these crystals out with. And I don't know, I think I'm going to fill this mason jar up pretty darn quick. Okay, I found a paint stirrer. I'll use the end without the paint on it so I don't contaminate the crystals. I also found a little casserole dish to put down here to catch errant flakes so they don't wind up on my dirty workbench here. Ooh, these crystals are tough, even with the paint stirrer. I mean, I'm getting them looser, but stuff right around the edge of the beaker. Wow, I don't want to break the beaker. I guess it's coming. It's just not coming easy. But I got a lot more crystals loose. I hope that color is showing up. They are just an amazing blue color. Deep blue. They're drier than I was expecting. I think they're still a little damp, but they're drier than I was expecting them to be. Especially down here towards the bottom of the beaker. I think there's still some liquid down here. Let me see how well this paint scraper or paint stirrer is going to do over here on this. Oh, I don't know about this. This one's packed pretty hard. I don't know how I'm going to get these out of here without breaking the beaker. They did too good a job of evaporating this stuff. Actually, I mean, I might be risking a runaway, but I could put it on the heat and melt that, and then get the puck of it out before it melts all the way through. It just melted at the edges and at the bottom. That's a possibility. So, yeah, I don't know how I'm going to get all the crystals out of either of these beakers. There's a hard puck at the bottom of this one too, and there's a thick layer along the wall here that just doesn't want to come off. It's on there pretty darn tight, pretty hard, and I'm afraid if I hit it too hard I'm going to break the glass, which I don't want to do. I break enough glassware as it is accidentally. Okay. I am managing to get a fair number of crystals here, though. Enough for an experiment, anyway. Probably several experiments. I don't even know if I'm going to be able to get any nitric acid out of this stuff. I might want to try a small-scale experiment before I go all in on this, you know? Just to make sure I can actually get something out of it. Now, that's about all I can dig out with this paint stirrer. You know, get some more off the sides. Where it's thick there, and at the bottom, it just doesn't want to come off. Yeah, I don't want to dig at it with a metal tool because I'm afraid I'll just punch right through the glass and break it. So I have to think about that. Think about that. This over here is still dripping a little bit. Taking its time. I'll see if I can get the crystals out of that once it's done dripping. But, yeah, I'm filling up the mason jar pretty good. Got enough here for an experiment anyway. I suppose I could just use water to dissolve the rest of the crystals out of these beakers, and then I can always recrystallize it again if it turns out that this is a worthwhile experiment. Yeah. Okay. So I think what I'm going to do is I'm going to set up for a small-scale experiment on this stuff before I go to too much more trouble with this. I mean, it hasn't been too much trouble now. It's cost me a little bit of electricity to run the hot plate for a few weeks. That's about it. You know, otherwise, I've just done my own thing while it's evaporated. But, alright, let me set up for a small-scale experiment. Okay, well, I am managing to break this stuff up in this beaker. It's coming out in chunks. The whole puck on the bottom is spinning. I don't know if that's showing up, but the whole puck on the bottom, I think I could break it up. So yeah, okay, good. Yeah, all the stuff in this beaker has broken up. So, alright. That's good. Now this stuff is a slightly different color than this stuff. I don't know if I should mix them or, well, it should be pretty much the same stuff. This should have maybe a little bit of copper sulfate in it. This shouldn't have any copper sulfate in it. So maybe that's accounts for the slight difference in colors. So, yeah. I think for my small scale test, I'll use a little bit of both. And we'll see what we get. And then, you know, if it's a good reaction, I'll just combine it all into one storage container here. Alright, let me get set up for that test. Okay, for the small scale test, I got my small beaker here. And I'm going to put some of both types of these crystals in here. Not going to measure it, just going to throw some in. And roughly equal amounts of both kinds. Alright, in there. Now let's put this in the fume hood, and we'll put some heat and some sulfuric acid on it and see if we get a cloud of orange fumes coming off. That's going to be my test about whether this is going to work or not. it's only been a couple of minutes. This really hasn't even had a chance to heat up any. And we've got some kind of bubbling going on in there. I've turned the fume hood on just in case those fumes are nasty. Not sure what's going on. Don't see any color to the fumes yet, so I don't think we're getting any nitrogen dioxide. It looks like it's mostly steam. We may just be dehydrating those salts in there. But you know what? I think I'm going to close the door just in case there's some kind of runaway reaction here. This is it's getting more violent by the minute. Huh. Let me put my gloves back on. You keep an eye on it for me while I'm doing that. I gotta still get my glove on here. I may reach in there and take the watch glass off. I don't know. It's doesn't seem to be getting any worse. I'm just gonna take the watch glass off in case it was gonna foam up, but it doesn't seem to be wanting to do that. I don't know. Let's see. Not sure what's going on in there. I guess I'll leave it for the moment. You see all the condensation on the watch glass. I think it's just steam that's coming out. Probably the sulfuric acid is dehydrating those crystals, which are very hydrated. They have a lot of water in them. So I guess I'll just let it cook. Nothing much else seems to be happening. I was afraid it was going to foam up big, but no. Okay, we'll just let it cook and see if anything interesting happens. Okay, it's been a couple minutes later, and I so hope this is showing up on camera. Look at that. We have orange fumes coming off of it. That's exactly what I was hoping to see right there. Yeah. So, yeah, we're still boiling down here. We got some orange fumes coming up. So we're at least producing some nitrogen dioxide gas, if not outright nitric acid that we're boiling out of that stuff. That's exactly what I was hoping would happen when I hit that with some concentrated sulfuric acid and some heat. So, okay. That is a very good sign. Yes, I'm thinking I can make nitric acid out of this stuff. I can reuse some of my own waste products, reproduce some nitric acid, and keep my costs down. Excellent. Very excellent. I'm going to let this cook a little while longer and just see how it goes. Yeah, the orange color looks a lot darker to my eye than it does on the viewfinder. But it is showing up on the viewfinder. I can see it now. Okay. Alright, so I'm going to let this cook for a while and just see what develops. Alright, it has been a couple more minutes. The orange fumes have dissipated. Seems to be more steam than pretty much anything else coming out of there right now. Those crystals were quite wet. Plus, I know that they have a lot of water of hydration in them. So I think what I'm going to do is I'm going to add a little bit more sulfuric acid to it and see what happens. Yeah. Just add it slowly and carefully with a pipette here. And see what that accomplishes, if anything. So far, not much. And I still see crystals in there. They haven't all been used up. Okay. I'll let that cook a little while longer and see. Give it a little bit of a stir. See, my eyes deceiving me? I don't know. I might be seeing a little more orange fumes developing. Okay. Maybe I just didn't hit it with enough sulfuric acid up front to really dehydrate things and get the reaction going, because I think I see some more orange fumes now. Not really showing up on the viewfinder very well, but to my eye, yeah, above the foamy stuff there, I'm seeing orange. Okay. And a lot of steam coming out. So if I do produce nitric acid with this stuff, it's going to be fairly dilute. You know, when I set up my nitric acid producing rig and I use, you know, really concentrated dry sulfuric acid and dry sodium nitrate, I get pretty pure nitric acid out of the retort, close to like 97-98% pure nitric acid. So this won't be anywhere near that strong. Probably pretty dilute actually, but still I could use dilute nitric acid. Yeah, the orange color is pretty weak. Alright, but at least we were producing something there. I'm going to let it cook a little while longer and see if anything interesting happens. Well, it's been a few more minutes. There seems to be less steam coming out of it, and I'm getting consistently orange fumes out, just a low level of them. So I think I'm going to hit it with a little bit more sulfuric acid and see what happens, because I still see crystals in there. You know what's happening is, what steam is coming out is condensing on the watch glass until there's a drop, and then when the drop comes down and hits that hot liquid, there's a big puff of steam as it evaporates violently. Let me put a little bit more sulfuric acid in here. There's a lot of steam coming out, but there's orange fumes too. So it'll be dilute acid. I suppose I can always redistill it through my distillation apparatus and get it concentrated up to maybe 68%. If I decide I want to. That might be too much trouble to go to. I might just use it dilute, since I normally dilute the acid anyway when I'm dissolving base metals out of IC chips. So I normally dilute it by quite a lot, actually. So dilute acid may work just fine. So actually this seems to be working pretty good. Yeah, get more orange fumes there. These seem to be dehydrating. There's less steam coming out. Get a puff now and then when a drop falls in off the watch glass into it. I think this is going to work. Not bad for a small scale test, I don't think. Yeah, the orange really isn't showing up too well on the viewfinder, but trust me, it is there. Alrighty, I'm kind of stoked. Alright, based on what's going on in the fume hood, I would say that this was probably not a complete waste of time. So I've got a big mason jar here full of mixed nitrates, mostly copper nitrate feedstock, which I managed to clear out one beaker. This beaker, I managed to get most of it off the sides. It's still got a solid puck on the bottom. I'm not sure what I'm going to do about that. This one over here is still draining. I'll see if those crystals will come out of there, but I'm going to need another beaker or another mason jar or something to store them in. That one's full. So I will have plenty of feedstock when I set up my big nitric acid production apparatus, which I maybe do not in the not too distant future, and see if I can make some decent nitric acid out of this stuff. But that's going to be in another video. I think this one's long enough. So anyway, thanks for watching. I hope you found this somewhat interesting, this weeks and weeks long experiment. I hope you found it somewhat interesting. If so, give it a like, give it a thumbs up, subscribe to see future videos, including the one where I try to turn this stuff into nitric acid that I can use. And check out my second channel, ElectroGeek64. Subscribe over there too. And press the little bell icon in both places so you'll be notified when new videos come out. And thanks again for watching. I'll see you in the next video.